So good morning everybody. My name is Arpan Ghosh. I have completed PhD in physics from Indian Institute of Technology, Indore. Currently I shall be going to discuss about Bragg's law. So first of all we have to know what is X-ray diffraction. So X-ray diffractions are basically X-ray will incident on the crystal planes, then diffraction will occur, and Bragg's law is related to this X-ray diffraction. So first of all, what we will do, we will consider a crystal plane. These are the atoms on the crystal planes. These two planes are parallel planes. Suppose the interplanar spacing between these two parallel planes is D. Suppose we are considering this is one X-ray, this is another X-ray. Now this is the perpendicular distance. Okay. Now for these two incident X-rays, these are the angle of incidence. Okay. Now from geometry we can tell if we consider these two lines, suppose this is O point, this is A, B, this is C, D and E. Then we can tell that if this is theta, then this angle is also theta. Okay. Now triangle OBC is a right angle triangle. Now for this triangle, if we consider sine theta, now this is 90 degree perpendicular. So sine theta means this OB by this D. So from this equation we get OB equals to D sine theta. Clear? Now similarly from triangle OCE, we will get also sine theta equals to OD by triangle ODC. ODC, OD by D. So OD equals to D sine theta. So here the total path difference is basically OB plus OD. That is equals to 2D sine theta. Now the constructive interference condition is that this total path difference should be equals to the n multiples of the wavelength of the X-ray. So 2D sine theta, so we will get 2D sine theta equals to n lambda. Now here n is the order of diffraction, lambda is the wavelength of the X-ray which has been used, and d is the interplanar spacing between the two parallel planes, and theta is the glancing angle. Now if we know n and lambda and d, then we can get theta. Similarly, if we know theta, n and lambda, then we can get d, that means interplanar spacing. Now what are the applications of Bragg's law? The applications of Bragg's law are to get about the crystal structure idea of a material, to get the lattice spacing. If we know d, the lattice parameter also we can get for the different crystal system. Also stress strain, if it is in the crystal, that also we can get. And for identification of the unknown material, we can get also the information about the unknown material. Thank you for visiting this video.